A bar graph is a way to display frequencies of various categories, and these categories typically are not going to be numerical ones. They're going to be, in this case, we have grades, or certain categories like yes or no for like a survey, things like that. And we can look at this data set and evaluate it similar to how we did line graph. So how many students made a B in the two courses? So we have final grades for two courses. B is going to be right here. This is the category. And what was the frequency of students that made a B, two courses? They both had 6. So both had 6 students that got that B. Okay, how many students were in each course? Well, to do that, we just need to calculate the running total. So we have 1 student here, and I'm looking at course 2 here. So I'll do course 1. I'll do course 1 like this, and then 2 like this. So we have 1 student for A's. This is for course 2. This is in blue. For course 2, we have 6 in B's, and I have 6 in course 1. For C's, I have 7 in course 1, so I'm going to have 7 here. And I have 8 in course 2. For D's, I have 4 in course 1. And I have 1 in course 2. And finally for F's, I have 2 in course 1, 2, and then 1 in course 2. So in total, it's going to be 10 and 9. It's going to be 19 here. And then it's going to be 3, 9, and 8, 17. So in total, we have 19 students in course 1 and 17 students in course 2. You can, of course, do this individually, right? This is going to be 6 for the red, 6, 7, 4, and 2. And then for this, it's going to be 1, 6, 8, 1, and 1. Okay, what percentage made a B in each course? Well, we know that there are 6 students that made the courses, 6 students that made B in each course, and then we know there's 19 in course 1 and 17 total in course 2. What percent of 19 is 6? Or what percent of 17 is 6? In other words, we just take how many we want to find, the part, divided by the total. So this is going to be for course 1, which is the red. It's going to be 0.3158. And then for course 2, we had 6 students got a B, and then out of the 17 total, part and the total is 0.3529. So very similar. The first one had 31.58%. This one had 35.29%. Very close. Now, what percentage passed, got an A, B, or C in each course? So we're just going to combine, add up how many got A, B, and C in each course, and then divide by the total. That's how we get the percentage. So for course 1, that's going to be, course 1's in the red, none for A. B was 6, and C was 7. 6 and 7 is 13. 13 passed out of the 19 total in the class. 13 out of 19 is 0.6842, or a 68.42% pass rate. For course 2, we have 1 from A, 6 from B, and 8 from C. 1, 6, and 8. It's going to be 14, 1, 15. 15 out of 17 passed. You could also say 1, 2. So 1 from here, 1 from here. 2 didn't pass. 2 minus 17 is 15. Just another way of doing it. So 15 out of 17. That's going to be a 0.8824, or an 88.24% passing rate for that class. Now, finally, let's just look at the variation or the spread of the data for Let me do it in blue here for course 2. I'm just going to do a kind of like a line graph for these, but I'm going to do it in a smoother curve. A line graph would look like this, and then go up to here, then go over here, then go down to here, and then stay flat. If I kind of make a smoother curve out of this data, it looks something like this. I go kind of like this, and then go up, and then kind of smooth out like that. This is how variation is kind of shown in statistics. But then for the red, right, we're going to have this point, then this point, then down here and down here. So for the red, the variation looks something more like this. Spikes and then kind of trails off like this. So just kind of different ways of thinking about the data, looking at the graph and seeing that, of course, we have a lot more of our data is right here in the BC range than here or down there. Now, instead of looking at these bar graphs, we can also look at a different type of bar graph, which is called a histogram. And a histogram really shows frequency of ranges of numbers. So previously, bar graphs are used for qualitative data, things that aren't numbers, whereas a histogram works best with quantitative data. And so this is how a histogram typically looks. In the previous one, you can see here, if I clean this up just a little bit, you can see that we have bars here that are distinct, that are separated by some space. Well, in a histogram, we don't really have that space because the classes tend to butt up against each other exactly. You can see here that we have a class here, class here, class here, 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 and here. They're exactly at this point, so that the class goes from 1 to 5, 5 to 9, 9 to 13, like that. Those are each of the classes, and then we're saying that the total numbers that fit in those classes are the heights of the bars. So what size of the classes or bins? It's going to be 1 to 5, or it's got a class size of 4 units. And what is the size of the total data set being represented? Well, that's going to be the frequency of all of the classes combined. It's the same thing up here, right? We added each one of these categories up, and that was the total number in the class. Well, it's the same idea here. So we have 6 here. This one's going to be 3. And then we have 9 here. This one's 7, right? I'm just going back to this, right? This is going to be 9. This one here is 7. 6 is right here. 3 is right here. This one's 5. That's going to be right here. And finally, 10. So the total is going to be 6 plus 3 plus 9, 7, 5, and 10. I'm getting 40 for the total size of a data set. Now, suppose the left endpoints are included in the class sizes. So this is an important note to make with the numerical representation, is that we have to have these endpoints included in the class sizes in some fashion, and that has to be stated. So in this case, we're saying that 1 to 5, we're going to say from 1 all the way up to 5, but not including 5 is going to be the class size there. And then we're going to include 5 in this one, but not include 9. We're going to include 9 to this one, but not include 13, and so on and so forth. And the only exception here is going to be 21 to 25. We're going to include both 21 and 25 because 25 has to be included in some case, and that's the highest class. So that's how we're going to read this data. So how much of the data is less than 13? Well, less than 13, right? 13 is going to be included in this class. So less than 13 is going to be everything from here on down. So all of this stuff here. We're not going to include 13, however, so we're not going to include this class, right? This one gets crossed off. We're going to include all of this stuff. So how much is in there? 9, 3, and 6 in total. Or 15 plus 3 is 18. 18 data points are included in these 3 classes. What about 17 or more? Well, 17 or more is going to include this one here, because that's going to be included in this class, and of course this one as well. That's going to be 5 and 10. So 15 data points are included from 17 or more, which of course the only thing that's not included in either of those two sets is from 13 all the way up to 17, but not including 17. Okay, finally, let's look at an actual histogram that we're going to make here. We have a data set here that's shown right here. I should put this in curly braces to show this is the full data set. And the shoe size of 50 male students. We're going to create a histogram using the class sizes shown in this table. So what is the class size? First off, you can see that the class size is 0.5 shoe size. And because 9 is included here, what's not included here, we're going to include the endpoints. And you're going to see that all of these shoe sizes are going to be only endpoints because of how shoe sizes work. Okay, 8.5 to 9, there is no 8.5. This is already listed from lowest to highest. There is no 8.5, but there are 2 9s. So both of these are going to be included in this first class. There are 2 numbers that fit in this class. Then we're going to say 9.5 to 10. We have 1, 2, 3, 4, 5, 6, 7, 8. These 8 numbers are going to be included in there. I'm just crossing them off to make sure I've counted them. 10.5 and 11. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 numbers fit in this class range. So that's through here, all the way through here. Okay, 11.5 to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 numbers fit in that class range. 12.5 to 13. 1, 2, 3, 4 are the only ones that fit in that class range. And finally, 13.5 to 14 is only 1 in that class range. Now, a good way to check this is that we know that there are going to be 50 male students, so we should have 50 numbers in total here. So let's just double check that. And I do indeed get 50 when I add all the way down the frequencies, so I'm fairly confident I didn't miss anything. Okay, now to create a histogram, we're just going to draw the bars on the graph. We have 8.5 here to 9. That's the first class. And that has a frequency of 2. 2 is right here. This is 1, 2, right? So I'm going to go up to 2, go all the way over, and then down. That's my first bar. Okay, the next class says 9.5. 9.5 is here, and then 10 is here. And so that's going to be 8 tall. So we're going to go 8 is right here. And so that's going to be something like this. We can do 10.5 to 11. That's going to be 21. 21 is right here. 10.5 to 11. 11.5 to 12 is 14. 14 is right here. 11.5 to 12. 12.5 to 13 is 4. That's just about here on the graph. That's where 4 is. So, and then finally, 13.5 to 14 is just 1. So it's just going to be up a little bit from there. Now, typically, like I said before, histograms are going to be, the bars are going to be butting up against each other to show that it's really a histogram. And the way we can do that really is just extend this a little bit, both sides, and kind of just split the difference here. So as you can see here, I've kind of filled out the histogram, looking a little bit more similar to what you would expect the histogram to look at. And we can actually look at this data and feel a trend for the data. We can see how it's grouped up, looking at the variation like I did before with the bar graph. And you can see here that I'm kind of starting off with 0 here, and I'm going up, and I'm spiking here, and I'm kind of going down and going off like this. And this shows somewhat similar to what's called the normal distribution in statistics. We're not going to be looking at that anymore, but this shows up all the time in a lot of real world data, this bell curve shape.